Welcome to GIS and Human Health, the Foundations of GIS by Dr. Ezra Özdenerol. Here is what we will cover with this presentation. First, we will discuss the definition of GIS, then the underlying reason for the use of GIS, what is geographic phenomena, and give examples, geographic entities in GIS, and give examples, GIS data models, and GIS data in the context of public health. By definition, geographic information systems let us visualize, question, analyze, and interpret data to understand relationships, patterns, and trends. In simple terms, GIS is a computerized mapping and data visualization system. This diagram shows us what composes a geographic information system. In order to do GIS, you need people, hardware, software, data, and infrastructure. The underlying reason for geographic information systems revolves around the purpose of effectively managing and analyzing geographical data. GIS allows users to do geographic queries, gain valuable insights, make informed decisions, and solve various problems related to geography, environment, urban planning, natural resources, and many other fields. Essentially, GIS serves as a powerful tool that enhances our understanding of spatial relationships and aids in better decision-making processes across diverse industries and disciplines. A geographical phenomena refers to any observable or measurable event, process, or occurrence that happens on or influences the Earth's surface or its atmosphere. These phenomena are typically related to geographical features, spatial patterns, and interactions between various elements of the Earth's environment. This geographic phenomena is something that can be named or described, be located, and assigned a time or time interval at which it or was present. Examples of geographic phenomena are pandemics, earthquakes, volcanic eruptions, climate change, erosion, urbanization, deforestation, ocean currents, migration patterns, coastal landforms. Types of map data. Discrete objects exist in a defined location and space. For example, a lookout tower could be a point data. Stream is a line data. A health service area could be a polygon. Continuous data exists everywhere, like elevation, represented by a raster. A geographical entity refers to a distinct and defined geographic feature, location, or area on the Earth's surface. These entities can vary in size and can range from small geographical features like a mountain or a river to larger ones like a country or a continent. Geographic entities are essential for organizing and understanding the Earth's landscape and its various components. Geographical entities are fundamental to geography, cartography, and various other disciplines that study the Earth's physical and human aspects. They help us classify and understand the diversity and complexity of our planet's landscape and its interconnected ecosystem. Geographical entities are represented as points, lines, and polygons in GIS. There are two models, vector model and raster model. These GIS models vary by the use of their data. For example, the vector model is best for discrete data. State boundaries, streams, health service areas are vector model data. The raster model is used for imagery and is best for continuous data, such as elevation or aerial photography. Vector model versus raster model in terms of computer representation. We actually look in the different geographical entities. This is how it looks. In the vector model, we'll see point features. And then whereas if we discuss about the raster model, we'll have a grid of cells. And then each of these, where these points are actually located, will be colored in different colors. And that actually makes, in this sense, the vector model more suitable and more accurate to represent points. The same applies with lines. So we have here on the middle a vector model based layer where we can see very clearly the sharp lines represent, for instance, infrastructures, where if we take into a raster model, we can see all the grid cells. And each we zoom in, it will become more pixelized. You will realize that actually a vector model, in this sense, provides a better solution to represent the infrastructure than a raster one, more accurate. In a very simple, similar application or principle is also with the polygons. On the right side, we have polygon features represented by using a vector model, whereas if we go here on the lower right, we can see this represented as a raster polygon. So We will use a vector model to represent geographical entities, whereas the raster model maybe will be used for aerial images and some other usages that we will discuss later in this course. Common types of GIS data used in public health. In the context of public health, several types of geographic information data are commonly used to analyze, monitor, and address various health-related issues. GIS data allows public health professionals to visualize and understand the spatial patterns and distribution of diseases, health facilities, environmental factors, and vulnerable populations. Some common types of GIS data in public health: disease surveillance data, health facility data, demographic data, environmental data, vector-borne disease data, health behavior data, socioeconomic data, vaccination coverage data, emergency response and disaster management data, so on and so forth. And GIS applications in public health, for example, disease outbreak mapping. GIS can track and map disease outbreaks in real time, helping public health authorities identify the source of the outbreak, trace its spread, and implement targeted containment measures. Spatial analysis of environmental health risk, access to healthcare services, disease surveillance, and early warning systems, vaccination immunization programs, vector-borne disease control, chronic disease and management, so on and so forth. Thank you.